Hello and welcome to this course. My name is Dimitris Orpheas Makris, PhD candidate and research associate at Sustainability Engineering Laboratory in Aristotle University of Thessaloniki. Our laboratory is part of the Neutron Pilot Project Consortium, and one of the Neutron goals is to educate European citizens about climate change, its effects, and how we turn this problem around. Over this presentation, we will unpack three big questions. What exactly is climate change from a scientific standpoint? What are its observable impacts on people and ecosystems today? And how is the world responding through mitigation and adaptation? To build a solid foundation, we need to first clear up a common confusion: climate versus weather. Weather, on the one hand, describes the mood of the atmosphere right now. Today's rain, tonight's breeze. Climate is its personality, the statistical pattern of those moods over at least 30 years. For example, checking tomorrow's forecast to plan a picnic is weather. Deciding which crops will survive in a region is climate. Why do we compare them? Public debates often misuse single storms or cold snaps to disprove warming. By showing that climate is an average of countless weather rolls of the dice, we inoculate ourselves against that error. Once we know we are dealing with long-term statistics, the next question is what controls Earth's long-term temperature? Enter the greenhouse effect. The greenhouse effect in general showcases how the sun's radiation can be trapped. Specifically for our planet, it displays its radiation equilibrium. Energy in, sunlight, mostly visible light reaches the Earth. Energy out, Earth re-emits part of that energy as infrared heat. And then we have the blanket effect. The greenhouse gases absorb some infrared and re-radiate it in all directions, trapping extra warmth. Now, what's the difference between natural versus amplified greenhouse gas blanket? The natural blanket keeps the surface temps around plus 15 degrees Celsius instead of minus 18 degrees Celsius that would have happened otherwise. Human activities have made the blanket thicker. Some key numbers that state the importance of human activities in generating greenhouse gases are pre-industrial CO2 was around 280 particles per meter. The NOAA record shows that daily values around 430 particles per meter in early June 2025. This is a 54% increase. Every additional particle per meter is like adding micro layers of extra insulation, small in appearance but large in effect over decades. Before we quantify irradiative forcing, let's be clear which gases we're talking about and where they come from. Think of the atmosphere as a ledger. Huge natural flows of greenhouse gases move in and out every year, but they almost balance. Human activity, though, adds a small extra line on the credit side. Small in percentage, but enough to tip the books. I will run through the four big long-lived greenhouse gases, plus a note on water vapor. The main source of greenhouse gases is the act of burning. Doesn't matter if it's from generating power, providing heat to homes or industries, even the automobile engines, and the act of burning forest. The four main greenhouse gases are carbon dioxide, methane, nitrous oxide, and fluorinated gases. If you were to keep something from this slide, it would be that Earth's forests, soils, and oceans inhale and exhale tens of gigatons of carbon every year. But when we add the human-made greenhouse gases, the inhale roughly equals the exhale. Those additional molecules create the increase in irradiative forcing. With this, scientists quantify all the blanket thickening influences. Radiative forcing measures the energy imbalance at the top of the atmosphere in watts per square meter. Positive numbers equal warmth, negative numbers equal cool. The IPCC AR6 puts total human caused forcing in 2019 at plus 2.72 watts per square meter relative to 1750. But why does this matter? This one metric lets us compare CO2, methane, aerosols, land use change, even solar fluctuations on the same scale. But can we prove humans are the dominant cause of recent warming? Multiple fingerprints say yes. Satellites saw the troposphere warming and stratosphere cooling, exactly the pattern expected from greenhouse trapping, not from a stronger sun. Burning fossil fuels dilutes atmospheric carbon, leaving a forensic tracer of human emissions. CO2 mixes planet-wide, so warming is global. Volcanic or solar effects would show stronger regional biases. In the next course, having already identified the problem and its cause, we will survey the evidence seen, observe changes in the physical climate, and what steps need to be made to turn this around.